reiterate. I believe we've talked about both of these already. The first is if we take a product inside of a radical, we can rewrite it and apply that radical to each factor of our product separately. So we can think of this as the nth root of A times the nth root of B. And again, it works in both directions. If you took the nth root of the same indexed root of two different factors, you could combine that into a single radical in this form. And then we also looked at the idea when we have the fraction involving these bases. So if you have the nth root of a fraction, again, you can apply that nth root to each individual part of the fraction separately. So the nth root of A divided by the nth root of B. Okay, so these are the two properties that, again, they work for these rational or the radical powers, any nth root, not just square roots. And so if we take a couple examples of these here really quickly. If you use the properties of roots to simplify. So here's just two problems to try this with, please. All right, so let's kind of talk through these. The first one is pretty easy to solve by hand. And you can use a calculator. I'll verify with a calculator. But by hand, we can use this first property in reverse. We have the square root of two bases, so we can combine that into one single base, 8 times 2, which is 16. And the square root of 16 is a common perfect square, so the answer is 4. Okay, now, if we verify this with our calculators, take the square root of 8 times the square root of 2, enter, it gives you 4, you verify it. Okay. The next one, again, we can solve by hand. It can be combined into a single fraction, 320 over 5. If we then simplify this, 5 goes into 36 times with 2 remaining. 5 goes into 24 times. And then we take the cube root of 64. 64 is a perfect cube that you should be familiar with. Also simplifies to 4. Okay, but if you use your calculator on this, and here's where students tend to make their mistakes, and that is the cube root. There is no button for cube root. Okay, so what you're going to need to do is you're going to need to either use the root key. So you can use or type the word root, enter the base, 320, comma, followed by the index for each of these. Now, you can either do this twice, or you may want to put it into this form first. Just put the root of 320 over 5, comma, 3 to combine it into the single fraction. Okay, and then you get your simplified form. Now, again, this only works if you have the most updated operating system on your calculator, and the ones that are on the computer do not. Your operating system should say like build 3.1 or 0, which is 3.10. And if you look at the build even on what I have here, and it's located in the About key, if you hit F1, the tools, and then scroll up to About, this one has version 2.0. So it's missing the ability to solve problems involving inequalities as well as some other things, and it involves calculating the roots. Okay, so if you don't have that, what you then have to do is you have to convert your numbers into rational power to enter them online. So you would take 320 to the power of, again, when you're rewriting it in rational power, or the rational power form, you take your base, 320, to the power of 1. It's an unwritten 1, so we are going to write that. And then an index of 3. So you basically get 320 to the power of 1/3, all divided by 5 to the power of 1/3. Okay, so a cube root is to a power of 1/3. A fourth root is to the power of 1/4, and so on. So if I were to enter this online, I'd get 320, or on the computer, calculator, 320 to the power of 1/3, and I'm going to divide that by 5 to the power of 1/3. And when I hit enter, it gives me my answer 4 that confirms what I did by hand. All right, questions on that? Okay, the most common mistake in trying to enter like a cube root or fourth root or fifth root is to think that it is the number, the index, followed by this square root symbol. Okay, but if you take 3 and then this square root symbol, this does not mean cube root. It means 3 times the square root of whatever you type next. And so be very careful on how you enter that.